I want to take a look at a different version of a spinal cord model. Here we see a cross-section through the spinal cord, and this happens to be a thoracic region of the spinal cord, and we don't have the bone associated. Now I can tell this is thoracic region because it has many of the features we need to know from the sympathetic nervous system. But first, let's just do an overview of the entire spinal cord. I'll look at both the cord itself and the picture below, and then we'll focus in on some of the other pictures. I can tell that this is the ventral side of the cord because we know that in the front of the cord we have the ventral median fissure. And again, on the diagram on the bottom you can see this large fissure to the front, the ventral median fissure. We can see on the posterior aspect of the cord the dorsal median sulcus, and on the diagram below the dorsal median sulcus. And then as we work our way laterally, there's a slight indentation, the dorsal intermediate sulcus, and here we can see the dorsal intermediate sulcus. And then where the rootlets are entering the spinal cord on the dorsal side, the dorsolateral sulcus, and here we can see the dorsolateral sulcus, again the dorsolateral sulcus. And ventrally, where the rootlets are leaving the spinal cord, we have the ventrolateral sulcus. Here's our ventrolateral sulcus, and in the diagram portion, the ventrolateral sulcus, the ventrolateral sulcus. Now if we look at this spinal cord, deep within we see the gray matter in its somewhat H shape, depicted here in the cord and in the diagram, and we can see the dorsal horns and the ventral horns of the gray matter, the dorsal horns and the ventral horns. But we know this is a thoracic portion of the spinal cord because we also see this rather abrupt and pointed lateral horn of the gray matter. Here's the lateral horn and the lateral horn of the gray matter. Also on this cord we see a much better version of the ventral white commissure. Here we see the ventral white commissure. Now because this is thoracic cord, we know that we can look at the regions for the sympathetic nervous system. So I want to focus on this lower portion. I'll do the diagram first, and then we'll talk about the cord model itself. In this diagram, they have color-coded some things, and the yellow represents the general somatic afferent, the green is the general visceral afferent. Afferent will be information coming into the spinal cord. The red and the black are general somatic efferent and general visceral efferent. I won't worry so much on this model about the somatic versus the visceral, but I really want to focus more on the afferent versus the efferent. For the sympathetic nervous system, the red in our sympathetic nervous system represents the preganglionic fiber. It will have its nerve cell body in the lateral horn of the vertebral column. Then its axon will pass through the ventral horn of the gray matter, out through the ventrolateral sulcus, through the ventral horn, or excuse me, the ventral root of the spinal nerve, and pass into the spinal nerve. Then it will leave that spinal nerve via a white ramus communicans to enter the paravertebral ganglion. So we know that this red represents the preganglionic fiber of our sympathetic nervous system. Now they do not depict the postganglionic fiber on this model. That would leave this ganglia, and it may go through the gray ramus communicans back into the spinal nerve and follow the spinal nerve out, or it may travel up or down to another sympathetic ganglion before rejoining a spinal nerve. So we'll go back over that one more time. The sympathetic nervous system, preganglionic and postganglionic fibers. The preganglionic fiber has its nerve cell body in the lateral horn of the thoracic and upper lumbar spinal cord. The axon will then travel out of the spinal cord via the ventral horn and the ventral root, join the spinal nerve, and then pass through a white ramus communicans to enter the paravertebral ganglion, also known as the sympathetic chain ganglion. Now they depict essentially the same thing on the upper part with the model. So in the model here we can see the gray matter of the spinal cord, And we can also see the ventral roots and the dorsal roots. And here again they use the color code for the red and the black and the yellow and the green. Sensory information enters the cord via the dorsal root and the dorsal rootlets. And the general visceral afferent will have its nerve cell bodies in this dorsal root ganglion, as will the general somatic afferents. On this model, what we see is very similar to the diagram below. The information, the efferent information leaving the spinal cord goes through the ventral rootlets into the ventral root and into the spinal nerve. Now on this model, they depict a few things. That spinal nerve we know should divide into a ventral ramus and a dorsal ramus, and the dorsal ramus is usually much smaller than the ventral ramus. And then we see these two little knobs coming out the front. These represent the white ramus communicans and the gray ramus communicans. So the spinal nerve dividing into a ventral ramus, a dorsal ramus, and off of that spinal nerve, the white ramus communicans and the gray ramus communicans.